Welcome to IGCSE Math, course code 0580 and 0980. In this course, we will cover both core and extended math and include the following chapters like numbers, algebra and graphs, coordinate geometry, geometry, mensuration, trigonometry, transformation in vectors, probability, and statistics. So the first chapter is numbers. So let's start with chapter number 1, and that is numbers. In this chapter, we will cover the following topics. The first one is types of number, then it is sets, powers and roots, fractions, decimals and percentages, ordering, the four operations, indices, standard form, estimation, limits of accuracy, ratio and proportion, rates, percentages, using a calculator, time, money. In this chapter, we will also cover the topics from the extended one. Now, what is a number? So, number is an arithmetic value used to represent quality. Numbers are used in everyday life. Your birthday has a number that tells the day, the month, and the year you were born. Similarly, numbers are used to keep track of time. We use clocks that show us time, we plan our day and events according to the time. Numbers are also involved in buying and selling too. To count money and the units of an item, we use numbers. Now, what are the types of numbers? So here we will discuss only two types of numbers. So natural numbers are the numbers that are used for counting and are the part of real numbers. It always starts from 1, not from 0, and it goes till infinity. The next is integers. Integers are represented by z or z. It starts from infinity and go till infinity, like 0, 1, 2, 3, 4, and so on. In this direction, it is -1, -2, and so on. So it starts from infinity and it goes till infinity. There is a clear difference between the natural number and the integers. Natural numbers are always positive, while the integers can be negative as well as positive. Natural numbers has no zero, while the integers can have zero. Zero is included. Keep in mind that all natural numbers are integers, but all the integers are not natural numbers. A factor is a number that divides another number in such a way that there is no remainder. For example, we have a number that is 28. 28 is divided by 4 and we get the answer is 7. So this 7 is a factor of 28. If you write it like this, 7 times 4 equals to 28. So this is also a factor and this 4 is also a factor of 28. Similarly, if we write 42, so 42 divided by 6 equals to 7. So here in this case, 6 is also a factor and 7 is also a factor of 42. The next is multiples. What are multiples? So multiples are the numbers you get by multiplying a number by another number. Suppose if I write 5. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, 5 times 6 is 30. So all these are the multiples of 5. Similarly, if I write the multiples of 7, so it has to be like this. 7 times 5 is 35, 7 times 6 is 42, 7 times 7 is 49, 7 times 8 is 56, and so on. So we can have multiple number of multiples for the 7. Now what are prime numbers and what number will be called as prime numbers? So those numbers which are greater than 1. The first is greater than 1. Second thing is that those numbers which are divisible by 1 and itself only. 1 and itself. Suppose I take a number 11. I have to check it that is it a prime number or not. So if you divide 11 on any other number, like you cannot divide it on 2, 3, 4, 5, 6, 7, 8, 9, 10. It can only be divisible by itself. Like 11 divided by 11 will give you 1, and 11 divided by 1 will give you 11. So this 11 is a prime number. Prime numbers always starts from 2. The next prime number is 3. 4 is not a prime number, then it is 5. 6 is not a prime number, then it is 7. 8 is not a prime number, 9 is not a prime number, 10 is not a prime number, 11 is a prime number, 12 is not a prime number, 13 is the next prime number, 14 is not a prime number, 15 is not a prime number, 16 is not a prime number, 17 is also not a prime number. Yeah, 17 is a prime number because it is divisible by 1 and itself. 18 is not a prime number, and then it is 19, which is a prime number. Then it is 20, it's not a prime number. 21 is not a prime number. Then it is 22, 23. 23 is a prime number because this number is divisible only by 1 and itself. So prime numbers are those numbers which are greater than 1 and which can be divided only by 1 and itself. No other number can divide it. Why 1 is not a prime number? The reason is that in the definition of the prime numbers, we said that it's necessary that a prime number should be greater than 1. Okay, so that is the first condition, that all the prime numbers should be greater than 1. This is the first condition. The second condition was that it should be divided on 1 and itself. It's a prime number, but one of the condition is that it should be greater than 1, and 1 is not included in this way. That's why 1 is not a prime number. The next is square numbers. A number obtained by squaring an integer. How? I have a number 16. If I say this 16 is a square number, but how? I have to prove it that this is a square number. You know that the square of 4 is 4 times 4, and 4 times 4 is 16. So in this way we can say that 16 is a square number because we have obtained it by taking the square on the 4. Similarly, 1 is also a square number, 4 is also a square number, 9 is also a square number because 1 can be obtained from 1 times 1 or 1 square. Similarly, 2 times 2 give us 4 and it's 2 square. So it means 1 is a square number, 4 is a square number, and same like 3 times 3 is 9. 3 square give 9, and 9 is a square number. The other square numbers are, after 1, 4 and 9 it is 16, then it is 25, then it is 36, then it is 49, then it is 64, then it is 81, and then it is 100, and so on. The next is cube numbers. What are cube numbers? So when you take cube on an integer and the result of that will be a cube number. For example, I have 2, and if I take a cube on this 2, it means it is 2 times 2 times 2, and 2 times 2 is 4, 4 times 2 is 8. So this 8 is a cube number. Similarly, 1 is also a cube number because if you take this cube on the 1, it gives 1 times 1 times 1, and it's again 1. So 1 is what? That is a cube number. Okay, 3 cube give you 3 times 3 times 3. So 3 times 3 times 3 is 27. So 27 is also a cube number. So the first cube number is 1, the second is 8, then it is 27, then it is 64, then it is 1, 25, and so on. Now what are square roots? The square root of a value is the number that when multiplied by itself equals that value. For example, if I say 16, so I will take a square root on it. It is under the root 16. Now you know that 16 is also equals to 4 times 4. I will write it under the square root again, and this is 4 square and 16 is there, so you can cancel this square root with this 2 because the square root is equals to 1 over 2 most of the time, although its value changes in some cases. Similarly, suppose we have another number, suppose it is 25. So the square root
25 is under the square root, so 5 times 5 is
under the root. Now 5 times 5 can be written as 5 square and under the root. So this under the root is cancelled with this 2. and we got only 5 here. So that's why we say that the square root of a value is the number that when multiplied by itself equals that value. Here we have multiplied 5 with the 5 and we have taken that value. The value of the square root can be positive as well as negative. It can be negative like this. If I take the square root of negative 25, so it has to be negative 5 times 5, and that will give is negative 5. So in this case, the value of the square root is negative. We have another term, it is third. The square root of non-square integer is called a third. For example, the square root of 3 is a third. Why it is a third? Because 3 is not a square number. This 3 is irrational because after simplifying it gives a value which will be in the decimals or in the fraction. What is a cube root now? This is a cube root now. There is always a 3 before the square root. This is called a cube root because when you put a value into it, suppose if I put a value as 1000 into it, so you know that 1000 can be written as 10 times 10 times 10, and you know that there is a cube root on it. So 10 times 10 times 10 will give you the answer is 10 cube. There will be a square, the cube root on it, and hence this cube will be cancelled with this cube root, and that's why we got the answer as 10. It's not only for 1000, there are so many. Another example, 3 is the cube root of 27. How? Let me explain. As we know that 27 can be written as 3 times 3 times 3. So this 3 times 3 times 3 can be also written as 3 cube. And now this cube will be cancelled with this cube root, and hence we got the answer as 3. That's why I was telling you in the beginning that 327 is the cube root of 3. The next is reciprocal. So reciprocal mean when you if a fraction. Suppose we have a fraction that is 2 by 3. So the reciprocal of this 2 by 3 is 3 by 2. So here we have left 2 by 3 and we got it as 3 by 2. Similarly, the reciprocal of 1 is 1 by 1. And the reciprocal of an integer is, for an integer, it is 1 divided by that integer. In algebra, the reciprocal of a is 1 over a. And this 1 over a can also be written as a power negative 1. Now, rational and irrational numbers. First of all, I would like to start with rational numbers. So what are rational numbers? Rational numbers are those numbers which can be written in the form of the fraction. For example, if I write 4 by 5, so this 4 by 5 is a rational number because it's written in the form of the fraction. All the integers are rational numbers. For example, I write an integer that is 3. So 3 is a rational number. Why it's called rational number? Because this 3 can be written as 3 by 1. So this 3 or 3 by 1 is considered as rational. In case if I write, so this is also rational because for rationality the negative sign doesn't matter. If I write 0 by 1, this is also rational because the numerator can be 0 but the denominator cannot be 0, so it is rational. The next is irrational numbers. Irrational numbers are those numbers which cannot be expressed in the form of the fraction or in the form of the ratio. Now what numbers are irrational numbers? So those numbers which are non-terminating and non-recurring. For example, we have a number, we have a decimal 0.33333 and so on. So this is a non-terminating number, so this is actually an irrational number. Same like in case we have the square root of a number that is suppose 16, so the answer is 4, so this is actually a rational number. But if you take the square root of such a number which is not a perfect square, which is not a square number, suppose we take the square of 9, not 9, if you take the square of 11, So the square root of 11, that is an irrational number, because this will give you such a value which will not be consisting of the fraction, and it cannot be compared as a ratio. That's why under root of 11 is an irrational number. Same like pi, which is always equals to 22 by 7. So this is also rational. There are some other rules in calculus that is called Euler's law. So Euler's law is also irrational. The other irrational numbers are, suppose, under root of 5, under root of 19, under root of 27, etc. Now, common factors. First of all, what are factors? So the integers, they divide another integer without a remainder. So we have to find out the factors and then the common factors. So for this we have a question. Suppose if we have to find out the common factors of 15 and 45. So in order to find out the factors of 15, I have to actually find out the prime factors of 15, which are the prime factorization method. So it is 15. 15 can be written as 3 times 5, as 3 itself is a prime number, 5 itself is a prime number. The next is 45. So 45 can be written as 3 times 15. So 3 itself is a prime number, and this is 15. Now 15 can further be simplified, and it can be written as 3 times 15. So this time we got the 3 and 5, and both are prime numbers. Now we have to write the common factors of both of them. So the factors of 15 are 3 and 5, and the factors of 45 are 3 times 3 times 5. So this 3 is common with this 3, and this 5 is common with this 5. So there are two common factors, and we have to find out we have to find out the HCF, or it's also called as GCF. HCF means highest common factor, and GCF is greatest common factor. So both are same. So the HCF, or the greatest common factor, for 15 and 45 has to be 3 times 5, and 3 times 5 is 15. So the HCF or GCF is what? That is 15 for 15 and 45. The next is common multiples. So multiples are the numbers that are obtained by multiplying two integers. Here now we have to find the common multiples. Suppose if we have to find out the common multiple of 5 and 7, and we are finding actually the LCM. So the multiples of 5 are 5, then 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. The next is multiples of 7. So 7 times 1 is 7, then it is 14, 21, 28, 35, 49, 56, 63, and 70. Now the common factors are 35, and here it's also 35. So not the common factor, the common multiple. So the LCM has to be 35. Similarly, the LCM of 15 and 30. We have to find out the multiples of 15. So it is like 15, 30, 45, 60, 75, 90. The multiples of 30 are starting with 30, 60, 90, and then 120, 150, and so on. So the common multiples are, here it is 30, 30, then it is 60 and 60, 90 and 90. These are common multiples. The LCM is the lowest common multiple or the least common multiple. So we have to pick the smallest one from all of them, and that is 30. So the LCM of 15 and 30 is 30. Write the answer in the comment and let me check. If it's perfect and your answers are correct, I will give you the marks. Thanks for watching.